Thanks for chiming in. This is gonna be a little longer video. And wait, before you jump off already immediately, because I know attention span, you just got 30 seconds to quickly check out YouTube. Bookmark it, save it for later, because I'm gonna try a little different thing here. I want to walk through a longer session where we're going to take an existing repository. I've got one with a Next.js application set up with Prisma, and we're going to add Nx to it. Check out how local caching works, how you can use Nx for running the tasks. We're going to do some fine tuning about the caching, and then we're going to look at the CI part. So there is already CI set up in there. We're going to update it to leverage Nx the best. We're going to see how remote caching works in that setup. Also, obviously, how we can distribute tasks with the Nx agents feature. And there's also Playwright testing the application, which right now takes roughly 20 minutes to run through. So we're going to see how we can leverage the task splitting feature, which is also called Nx Atomizer, how to split up these Playwright tasks and parallelize them much better, such that we can get it down to almost 8 minutes. So if you've got some time, definitely stick with me. As said, you can save it for later, or also use the chapters that I've got laid out for the entire video, such that you can jump to an interesting section right away and go from there. Ready? Let's go. So the structure of the repo is the following. So we have an applications folder up here, which has a Next.js based application. We have end-to-end tests, which are written in Playwright here that test our application. And then we have a bunch of packages down here. So we have some dashboard widgets, we have a database that uses Prisma, we have some sidebar widgets and various UI components. And so if we launch the application, and then go to localhost 3000, we can actually log in. So I can say alice@tasker.io. This is pre-seeded data and some super secret passwords. And you can see how I'm getting logged in. So this is like a Tasker application, so a task manager on steroids. So we even have project management here. We have different tasks. We have a dashboard with different things going on. You can even add new tasks in here. So feel free to play around with it. We're not going to spend a whole lot in the application itself. This is more like to have a real world application. But what we are going to do rather is add Nx to this repo. So right now, this is actually a monorepo which leverages PNPM workspace setup. And so you can see that by this PNPM workspace YAML file, which defines the various packages or projects that we have in this repo. So there's one in applications. Right now, we just have one app, but potentially we could have multiple ones. We have one end-to-end that's set up in here, leverage Playwright, and we have different packages down here. And so this is a monorepo in terms of the setup, but really what we do here is we modularize our application to not have all the logic here situated within the application up here, but rather we spread out things here into various sub-packages, such as for dashboard widgets, for managing database access and preceding, and various other things. Now, since this is a PNPM workspace setup, all of these different packages also have the various scripts that you need for each of them to run them, to build them, to serve them. They're all listed in the according package JSON. And PNPM comes with different commands that you can now use to run them. For instance, let's say we want to run the build here of our Next.js web application. So all we can do here is run PNPM -filter. We go here for Tasker web, and this is actually our application name. And then we say build, and this would now run the build task in here. And similarly, you can do this for all the other projects as well, whether it's about running tests or end-to-end tests for Playwright, or also linting for these packages. Now to add Nx to this repo, all we need to do is run Nx init. And so since we have PNPM here, we can run PNPM DLX Nx add latest init. You can drop the add latest, but if you have for some reason Nx already installed, this makes sure you get a fresh version from the repository. Now, when we run this, we get a bunch of different questions asked that help us to set up the repository. So first of all, which scripts need to run in order? This allows us to define which scripts need to follow a certain order. For instance, if we run the build of our application up here, we might need to run first the build of dependent packages if they are buildable. So if they have an actual build step. So for that reason, I'm indicating build here, and that should be it mostly. Next, which scripts are cacheable? Now, if we don't know upfront, we can actually configure that later, and we are actually going to have a look. But for now, we can just go through and say like the build is cacheable, probably end-to-end test as well, linting is cacheable for sure, testing as well. And then that's mostly it, I would say. The dev server is something that we run continuously, so that's for development purposes, and usually that's not cacheable. Finally, is there any outputs that are custom or special, Nx would already cover dist, lib, build, and coverage automatically, which are common ones. But if you have some custom ones, you could actually specify them here. We're going to do that later to do some fine tuning. So for now, we just skip this section. Similarly for end-to-end, for lint as well, for test as well. And then Nx is going to install different dependencies. And then Nx also asks about some plugins that could be added to this workspace based on the type of project it found. Now, we're not going to do that now, but we could potentially later. Plugins are usually just an enhancement on top of what you already have. And so with that, we are set up. If we look at the structure of what changed based on this install here, we can see the git ignore got updated with some Nx specific things like the local cache and some workspace data. We got such an Nx JSON. The Nx JSON is mostly a file containing high-level metadata about what the cacheable operations are. And these are basically the ones that we defined during the setup process, and we can revisit them later. We got some update in the package JSON. Obviously, Nx got installed, but that's pretty much it. There's no other dependencies that got pulled in. And then there's just the updating of the PNPM log file. So now that we have Nx installed in this repository, we can leverage the Nx specific commands rather than going with the PNPM ones. So we have this package JSON, which we did use before to run the build script of this web application. And so rather than running a filter command at task or web build, we can now use an Nx specific command, which is PNPM Nx. We give it the name of the task, which in this case is build, and the name of the application, which is tasker web. The name of the application is basically defined here in the name of the package JSON. And so let me run this. As you can see, it invokes here the next build part, which is exactly what is specified here for this package JSON script. And so an advantage of that as well is that we can now leverage the caching that comes with these commands. Right now, the tasker web build took 19 seconds, but if we run this again for some reason without changing anything, you can see it's like 59 milliseconds. And so this is because in the Nx JSON at the very root here, we defined that build is cacheable, and so this will be cached automatically. Similarly, you can also run tasks recursively for the entire repo, so for all the projects that have a matching script. So rather than running pnpm-r and then build, which would run recursively the build for all the projects that have a build tasks or tests, etc., you can run nx run many -t for target or task, and this would be then build. You can even specify multiple ones. So we could say build and test, for instance, and this would now run them in parallel for all the projects that it finds in the workspace. Now you can also see that the caching here again hits because, for instance, the build we just ran before, so this one doesn't get rerun, but it just gets printed out, so it is super fast, and instead it runs, for instance, the test for all the other projects that are in here. And apparently in this specific repo, there's only the application that has a build command. So that was the only one that was run for this build task. So when Nx caches an operation, it caches the terminal output, but also artifacts. This can be build JS files, CSS files, etc. And so if you look, for instance, specifically at our sample application here, which is this Next.js application, we get obviously the terminal output. And so if I run pnpm nx build at task or web again, you can see this is cached. So we get the exact same terminal output printed out again in colors. So you don't even notice the difference apart from this line at the very end that tells you this has been cached, but it also restores artifacts. And so as part of a build process, we get this next folder as well that Next.js creates when you build the application. So if I delete this and I rerun the build operation again, you can see this gets restored, but for some reason the next folder doesn't show up. Now this was intentional. I knew I was missing this one, but I wanted to show you how you can fine tune this. By default, Nx already captures folders like dist, build, or other types of folders that are common across applications. But this one here is very specific to the Next.js setup. But we can go and fine tune that. And so if we go to the Nx JSON, and then we go to this build target, we can fine tune what gets captured as part of the caching. And so as part of that, you have inputs that define what should be cached in terms of files. We don't really need to change anything in this specific scenario, but you also have outputs that need to be captured. And in this case, we want to capture the project root. And this is a special placeholder that Nx gives you, and then .next, which is the one that we want to cache. So if you now go back and open up here our Explorer and scroll up here where we see our web application, and now I run the build again, you can see it first runs through again because we changed the fundamental file, which is the Nx JSON. So we need to invalidate the existing cache. So if I now rerun it again, it will be cached. And as well, if I remove here the next folder and rerun it again, you can see that the next folder gets restored again. Another very common thing that you keep doing in a monorepo setup is define dependent tasks. So meaning when you run, for instance, the build for this application, you want to make sure that it also runs the builds for dependent projects. Because sometimes the application actually depends on the pre-built outputs of these packages. And if you go to the Nx.json, you can already see some of these settings configured. When we did set up this repository during the Nx init phase, we defined that the build needs to run in order, meaning that whenever we run a build on an existing project, then we first run it on all its dependent projects, which is given by this caret symbol here. And so this makes sure the build can complete successfully and we don't have to worry about ordering, because that is being handled automatically by Nx, even when we run many of these tasks in parallel across the repository. Now for this specific repository, we have another use case for such a task pipeline. So if you open up here this package.json file for this Next.js web application, you can see these different scripts that have been pre-configured by the Next CLI setup. And so you can see there's the dev command that we just run in dev mode, we have the build and we have the start. Now start specifically is being served off the Next folder, so it requires you to run the build beforehand. And we can see this immediately if we delete this folder and then we run PNPM Nx start at tasker web, it would fail saying that there is no Next directory. So what I would rather have to do is run the build first. And now we get the Next folder. By the way, we also get it cached because we ran it before. And now we run the start command again. And it would now be served off that local folder and work properly. Now we don't want to do this manually, and we don't want to concatenate these things in a weird way where we first run build and then run start afterwards. What we can rather do though is define such a task pipeline that we have defined here, but for this local script. And so rather than doing that here in the Nx.json, which is global for the entire repo, which could totally make sense if you have multiple Next.js applications in here, I'm going to do it locally in this package.json. So if I scroll down here, I can add an Nx node in this package.json file where I define targets. And specifically, I'm saying here, whenever you run this start target, this depends on the build target. And so it's very similar to what we have here in Nx.json, but I don't define this caret symbol, which means this is a local script. So whenever you run start, run the build of the same project you invoked start on, which in this case would mean we run this, Nx automatically understands the relationship between this and this build script and would trigger this automatically for us. So let's have a look. If we go here and delete this again, and now I'm just going to run Nx start at tasker web. And you can now here see already a hint where Nx says running target start for project and one task it depends on. And in fact, like you can see, it runs the build first. And once the build is done, it will run the actual start script. So whenever you add Nx to an existing workspace, it is able to figure out the relationships between the packages mostly automatically. And so we can run, for instance, Nx graph, and that would open up here the project graph. And if I show all projects here, you can see there are these different relationships. So Nx automatically detects that there is the web application that depends on all these packages. And some of these packages you can see also depend on the sub packages as well. And it does so by following simply here the package.json file. So if we open up here the web application, you can see that we leverage here the PNPM workspaces syntax to reference packages that are local and in this workspace and that need to be linked to this application specifically. There are, however, sometimes tasks that cannot be detected because they're simply not linked. And this linking is important for when you define a task pipeline such that Nx knows what are the dependent tasks such that you can figure out what to build first, for instance, or if you use something like affected commands, which in Nx allows you to build just a sub part of the graph based on what got affected. So meaning if I change this sidebar here, it would only run these two projects on CI. For that to work, we need to have the graph that is properly representing the actual situation. Now, in this case, for instance, you see or you notice that there is this tasker end-to-end web that doesn't really depend on anything. And that's because there's no real connection between those. What happens when you run this Playwright setup is that it will spin up the application, and that is defined here in this Playwright setup. So if I go in here, you will see there is like a product web server that says what is the command that needs to run to spin up the actual application, which is this one here. And then Playwright just runs the different specs. But there's no real import from the application itself. Now we still want to have this connection though, because whenever we run some changes on the task web, we want to make sure the end-to-end tests run automatically as well. And so we can establish such a relationship by leveraging implicit dependencies. And so I can go into the web application, and I'm gonna again do this locally here in this package.json of this Playwright setup. And I'm adding here an Nx node, and then I can define here implicit dependencies, and Copilot already suggests me that I want to add the task web. Now, if I go back to the graph, it should already have reflected the change. And in fact, now you see this arrow here with an implicit marker on top, which says that this is something that we defined implicitly in our configuration. And so now these two are linked and we have a proper representation of our workspace in this Nx graph. To benefit from a lot of the features such as caching, also on CI, where usually the pain points come in, Nx comes with a commercial add-on, which is a product. If we go to nx.dev, we can see here NX Cloud, which is a commercial product that directly integrates with Nx, comes with a very generous free tier, so we're gonna use that. And we can use that to set up remote caching for our CI pipelines. And there's also a feature that allows you to distribute tasks and parallelize them much faster, which is called Nx Agents. And most interestingly, which we're going to use for our Playwright tests in the workspace, is to split tasks into much more fine-grained pieces to have a more effective distribution. But before we can jump into all of them, we need to actually connect our workspace with NX Cloud. And so if we go to the application, I already made an account for it. So you can just sign in, you can create such an org, and then we can connect our workspace. To connect the workspace, you can either just start from right here or directly go into our repository and start from there. And so if I go back in here, so we have Git obviously set up here. However, this is just a local repo, and it works best if we can push this up to GitHub, because then NX Cloud will be able to directly connect to it and pre-configure the setup for us, so we don't have to do all the things manually, which is already really nice. So I'm gonna do and push this up to GitHub for now. And I'm using here the GitHub CLI, which is really neat. Push up this local repository. Let me call this Tasker course, which sounds good. Push this to my org. This can be public, it's fine. And so now if I go to task or course, we can see we pushed everything up here into our GitHub repository. Now that we have that, we can go back into our local project and run nx connect. And that should run us through the entire process of getting this configured. And so this opens up now a new URL in my browser. I'm already logged in, so I can jump over that part. You can see our task or course repo was already pre-configured because that was obviously inferred from the local project where we started with the NX Connect command. I want to use an existing org. This is an NX Cloud organization, so there's just a way to group projects and workspaces, which then obviously comes with configuring access rights, etc. at an organization level. It's pretty much the same concept as GitHub orgs. So I want to add that to that existing organization. And then I can basically be guided through the setup. So what here is being recommended is that NX Cloud is going to push a PR to this branch name based on my main branch, which is fine, and pre-configure it for me. So that looks pretty neat. So let's hit that connect workspace button. And so this looks all good. Let me directly go to the PR, I guess. And so here I'm back in my task course repo, which we have also open here. So let me just move this over. You can see there's a new PR that has been opened. There's already some checks running. That's because I already have a YAML file in here, which runs checks, which is neat. And so if we look at the changes, you can see it did some formatting, which I guess is fine. And then it added here an NX Cloud ID, which connects my local repo with the remote NX Cloud repo. Now here it already runs some of the checks. However, my local CI setup, which is this one here, is not really optimized for NX yet, because what it does is basically simply install a bunch of different things and then run PNPM tasks, which NX won't be able to capture, and so therefore caching won't work, etc. So let's do that in a second step. For now, this looks good. Let me just merge this pull request. So if I head back in here, I pull down the changes. We now have NX Cloud properly connected to my local workspace. So if you have NX Cloud connected and we want to leverage all the different features, we want to make sure to update our existing CI config to actually use NX commands such that like caching can be captured by NX Cloud and accordingly restored. Now here you see the main part is basically here where we run the checks for building, linting, etc. So we want to change them with NX specific commands. As a side note, if you don't have a CI config yet, you can actually go and generate one, which can also be a good hint for generating a scaffold and then just picking out the pieces that you might need in your existing config. So let me do that really quick. And in order to be able to do that, we need to pull in here the add NX workspace package. And let me install that because that comes with a scaffolding mechanism to generate such a CI setup. And to generate it, we can run nxg, which stands for generate, CI workflow. And I will ask me now which provider I'm using. In this case, we're using GitHub. This can be just CI YAML, that's fine. And now you can see it created a CI YAML file, which lives up here, which is a super simple one. It just does a bunch of setup here for PNPM, and further down then you can see how it runs the various NX commands. Another thing it also did, because if you look at the file changes, it also included here a change in NX.json, which is to make sure we invalidate cache whenever our CI config changes. Now this named input here is a way to define variables, caching variables that contain input definitions for cachings that we can reuse across different targets. Let's say, for instance, we want to have here in our build to always include all TSX files, but not markdown files. We could actually go ahead and define here a no markdown variable almost that says in the project root, capture all markdown files, but then negate that part such that no markdown files will be included. And then we could go up here and define here inputs that says here no markdown, right? And so that would then combine and make sure no markdown are being used as part of this input. Now you can dig deeper into those in the nx.dev docs. For this specific setup here, what happened or what got generated for us is this shared globals variable, which is a convenient name to define common globals across the workspace. And those shared global ones got then referenced or associated to this default one. And the default one is a special one that NX will always add to its input caching. And so in this way, we are saying whenever the workspace root, GitHub workflow, CI YAML file changes, make sure that you invalidate the cache at the global level. Now, in our case, this CI YAML was just an example that we generated. So we rather want to make sure that we include here this verify YAML. And so let me go and here update that, because we are going to delete the CI YAML file anyway. So for now, let me keep that as a backup here. And let's go back to our verify YAML file and adjust it accordingly. Now we've seen here in this backup file, what NX uses here is an NX command, and it uses NX affected. Now affected means it will only run those projects that actually got touched in the PR. The docs have some detailed explanation of how that works. I'm not going to go into the details here, but we can actually use a similar setup right away in our run part down here. And rather than running here the building and testing for all the packages, we can actually just run NX affected and then let's say run test and build. And once we have that, let's actually add and commit all these changes and push them to our repo. And so if I go over to my repository, you see here there's a GitHub action now in progress. So let me jump to the details here. You see the checks are being executed here via NX. If I created an actual PR, I would also see a comment being pushed into that PR by NX Cloud that will bring us to the ongoing run on NX Cloud dashboard itself. Now I can just jump directly there. I still have the link open. Let me refresh. We see here there's this in progress run, which is the one that we run currently. And here the runs are already completed. So you can see here the different runs that have been executed. There's like the one for UI, which is a test run as well. And here is our build for the web application. Now for now, these are cache misses because we never ran them on CI. If I go back here to my repository and I go into the CI log, you can see we see a nicely formatted output of the actual run without having all the logs just streamed in. And so you can see what tasks ran, how long they took, and you have also the link to that cloud dashboard that we just saw previously. When it comes to remote caching, NX Cloud provides you with fine-grained control over how that cache is being handled. So whether it is like read-only or read and write. On CI, you definitely want to have read and write access because you can read existing caches from previous runs as well as write new cache results such that upcoming runs can benefit from it. And so to configure that, go to your NX Cloud workspace and under settings, CI access tokens, create a new token. So I'm gonna go ahead and create a new token. I'll call that CI token, and I'm switching that to be read and write, which I wanna use for my GitHub actions. So you can generate a token, copy it. You can now see it here. Now I go back to my GitHub repository. I go to the settings, to the secrets and variables for my actions, and I'm going to define a new repository secret. And I'm going to call this here NX Cloud Access Token. And let me paste in here the token that got generated. Now, once I have this secret here, I want to expose it also in my CI config. So in our project, go to our verify YAML file at the very top and expose here the new token to my CI run. So basically I'm here naming this token NX Cloud Access Token such that NX Cloud can pick it up, and then I'm passing in the secret that I just defined on my GitHub action. With this CI token in place, I pushed up a new change that just updates the README. And so if we go to the actual run here and check what happened, you can see now we have a full cache hit on all 3 tasks. And if I go to my NX Cloud dashboard, I can open this up and see here that all of these have been a remote cache hit. So if you happen to run into a remote cache miss and you're wondering why that's the case, you can go to the NX Cloud UI, and let me pick up this one, for instance, which if I open up the run, we can see all of these have been cache misses. Now to debug why that was the case, you can click on one of them, or the one you're actually interested in, hit that compare to similar tasks button, which will then open up here a new UI where we can either paste in the actual run if we know which one we want to compare it to, or we can just compare it to one of the previous ones that happened. So let me choose this one, hit check for tasks, and then you can see here a diff output of why we resulted in a cache miss. And in particular, in this case, we can see that the verify YAML file, which is the CI configuration file, was changed because it has a different hash key now. And so therefore, this whole run here resulted into a cache miss. For every NX Cloud workspace, you can configure what the access level is to actually get cache results, whether it's read only or read and write. Now for CI specifically, you can provision CI access tokens and control the read-write permissions or read-only permissions there. For local access, you have 2 ways of defining such security levels. For ID access level, which means those basically that clone the repository and in the NX.json just have the NX Cloud ID, the default setting will be it is read-only. Now you could flip it here to read-write, or you could have your members log into NX Cloud and therefore just define such a security level on the personal access token level. To log in to NX Cloud, you can just go to your workspace that is already connected to NX Cloud and then run PNPM NX login. Now this will open up a link that will redirect you to NX Cloud. And this will now have generated a new personal access token that connects your ID to the specific NX Cloud workspace. Following that setting, an admin can now go to the actual workspace and change the personal access level to read-write, for instance, meaning that everyone that logged themselves into the actual organization here and is part of the organization itself as a member in this specific org can now locally benefit from remote caching. So if I run many here, locally in my workspace, it will be able to leverage the remote cache directly from here. And I will also be able to not just read it, but also write it back to the remote cache location. So remote caching is just one ingredient to make sure CI remains fast in a monorepo, because sometimes there are some worst case scenarios or you invalidate the cache where you still need to run a lot of different projects on your CI. And so the best way is to parallelize, ideally across different machines. And NX Cloud has that built in. So to enable that, we need to go into our verify YAML file, so our CI setup file. And we can do this even before installing PNPM packages. For now, in this specific setup, I'm just adding it right in here. So to enable such distribution on CI, we can use this specific command here, which enables NX agents. So the command is structured as follows. So we leverage this utility here, which is the NX Cloud package. As you can see, this is directly being pulled down, so you don't have to have it installed in your workspace. And then we use its command, which is called start CI run. Now this will instruct NX Cloud to distribute all the tasks that we run, which is basically all these that run here through the NX package down here, the Nx CLI, and to distribute them on 3 machines of type Linux Medium JS. Now, if you go to the Nx docs for CI and you go down here into the reference, you will see these launch templates, which shows you a set of different pre-built launch templates, such as here for Linux, where you see different Linux classes. This is almost like a Docker file that defines what steps need to be run for instantiating such a machine on NX Cloud. You can even define your own custom launch templates, but for that, please refer to the actual Nx docs. And so with that enabled, let's actually commit that and push it to our repository. If I now go to the NX Cloud dashboard, you can see how we now run on these 3 Linux Medium.js files. And you can see here the different agents, how they are being set up, and the node packages are being installed into these agent tasks. And so once the agents get instantiated, you can see here the commands being passed to the agents. Now in this specific setup, we just have 3 different tasks running, which run in parallel on one machine. So there's no point of instantiating more agents in this scenario here. So in the current setup, we have a Playwright test down here, which doesn't run on NX agents yet. So we have connected this workspace to NX Cloud, and we have also enabled NX agents to distribute them across 3 different machines on CI. However, the end-to-end tests are still separate. And so we can now directly move them in by changing our CI setup here, and we can comment out these PNPM filter commands down here, which run the Playwright test separately, but rather we want to run them in parallel as part of all the other runs. We can also make sure to go up here to our NX Cloud setup and make sure the build stops after end-to-end tests are run. And we might also need to adjust some of our Playwright settings. So if you go here, the end-to-end tests just run Playwright test, which in turn will trigger here the Playwright setup and leverage here the Playwright config. However, instead of running here the PNPM command, we want to run it through the NX specific command. Now we also want to make sure that the task pipeline is set up in a way such that it builds first the project that it needs to run the tests against. So in this case here, for instance, we run the end-to-end tests. So if you look at the graph here, we see there's the end-to-end project that depends on the task or web application. And specifically for the distribution on agents, we want to make sure that the build here for this application, for the Next.js app, happens before the actual end-to-end test runs. Because we want to run the Playwright test against a static output, so the built output of the Next.js application. And so for that to happen, we can go to the Nx.json and in the end-to-end test here define a depends on, and this should be build, but not just build of the same project, obviously, but downstream projects. In that case, the Next.js application. And so now we can actually go ahead and commit this and then push it to our repo. On the NX Cloud dashboard, we can now see our agent setup that runs the current tasks, which is the test and build and end-to-end. Now the build and test already run before the end-to-end one because that's based on the dependency that we just established. But we can see we cannot really leverage our agent infrastructure as optimally as we would potentially want because the end-to-end task is just a single block that runs on a single machine, so it cannot be distributed further. So for the distribution on CI to work optimally, we would need to be able to run these spec files individually, such that they could be run on different agents at the same time. And therefore, we would leverage a parallelization optimally. And that would mean, however, to duplicate these runnable tasks here into multiple ones. So we could have like an end-to-end CI -- and for each file, we could have one. For instance, let's grab here auth login, logout. We could have auth login, logout. And then go here and pass the according file to Playwright, which is actually possible. Now, this is definitely not practical, and we would need to also update this as we keep adding tests. So for that purpose, we can actually use the NX Playwright plugin, which can do this automatically for us. To add a plugin, run nx add nx Playwright, which will install the plugin in the correct version into our workspace. This also pre-configures the Playwright plugin automatically. And so if we go and have a look at the change that happened, we can see in the Nx.json, there's a new section called plugins, where we have the plugin listed and a target name for running end-to-end tests. We also see the package NX Playwright that got pulled in, as well as Playwright test. And in the end-to-end test package here, we see the end-to-end script here got replaced from Playwright test to the NX specific Playwright runner. Now the NX Playwright plugin automatically looks at the Playwright config as well as the package JSON for the corresponding project here and infers all the settings that have been configured here. And at the same time, it is also able to generate now one runnable task for each of these spec files. And so in order to have a look at those, we can run nx show project at tasker end-to-end web, which will open up a browser here. And we can now see there is the single end-to-end task that we already have in the npm script inside the package JSON, but there's also dynamic tasks now generated automatically. And you can see here, these are prefixed with end-to-end -ci, -- and the actual file that is being run. And down here, you see the underlying command that the plugin runs, which is nothing else than the Playwright test and passing it the actual file. Now, conveniently, if you have NX console installed, you can either open the package JSON of the corresponding project and click this icon, or also the according Playwright config. And if you click this icon, you will see the same view that we just saw in the browser, but directly integrated into your code editor. So again, here you see all the different targets that got generated based on the spec files that are in our project. Now with this setup, we can go and update our CI config. And so rather than running here the end-to-end test that runs the entire set of tests, we run end-to-end -ci. Let's also go up here and adjust here our configuration for the agents, such that it stops once all end-to-end CI tests have been run. And we can also actually distribute across 5 agents just to see the distribution in a much better way. Let's comment these changes and push them to CI. Going to the NX Cloud dashboard, you can then see how these agents are now being instantiated. And instead of having a single end-to-end test block that cannot be distributed, we can now leverage the infrastructure of having 5 machines run stuff in parallel, where each of them takes up one of these end-to-end tests automatically and spreads them across the infrastructure. All right, you made it. It actually even got dark around here. So we did a whole bunch of things now on this specific PNPM workspace, going from adding NX to it, to configuring local caching, running tasks, to setting up NX Cloud, connecting to the workspace, configuring CI access tokens, and much more. Now, if you want to learn more about the details, go to our docs on nx.dev. There's a dedicated CI section which has more details about these different features and some more surrounding context if you want to dig deeper in, for instance, defining your custom launch template or understanding how you can dynamically allocate agents for these different tasks. So I hope this was helpful. Let me know in the comments, like and subscribe, and I'll see you in the next one.